In this movie, let's revisit our chart of greenhouse gases. Carbon dioxide is the most important and also currently the biggest polluter. Carbon dioxide is colorless, odorless, and an incombustible gas. It goes into the atmosphere during animal and plant respiration, burning organic fuels like petroleum, coal, wood, etc., and decomposition of organic material. It gets absorbed from the atmosphere by plants during photosynthesis, and it also dissolves in the oceans. Unfortunately, we are producing more carbon dioxide than the natural sinks can absorb, and this is leading to accumulation of this greenhouse gas in the atmosphere. The increase in carbon dioxide has been a continuous activity since last century, and from 280 ppm, that is parts per million, it has risen to nearly 390 ppm today. The famous Keeling curve shows that this steady increase of carbon dioxide. The data is collected by scientists at Mauna Loa Observatory in Hawaii, a place not much affected by local pollution. The danger from carbon dioxide pollution is that it stays in the atmosphere for a very long time. 50% of carbon dioxide will degenerate in 40 to 50 years. The remaining 30% of carbon dioxide will be there till next 100 years, and the balance 20% will be around for more than 1,000 years. So what damage we will do today, the coming generations will have to face the consequences for a very long time. Methane is the second most important greenhouse gas. Methane is a colorless, odorless, and a highly combustible gas. It is 20 times more powerful than carbon dioxide as a greenhouse gas. The largest source of this gas is the agriculture sector, where the livestock waste, and rice farming are the main sources of methane. Second biggest source of methane is oil and gas production, mining for coal, and biomass burning. Natural sources of methane are wetlands and decaying organic matter in oceans and lakes. The concentration of methane has been increasing in the atmosphere since industrialization. It was 714 parts per billion at that time and has risen to 1,875 parts per billion today. Though the increase in the concentration has been slowing down in the recent past, it remains a very potent greenhouse gas. Methane is chemically active and breaks down in atmosphere in 10 to 12 years, so has a very short life, thankfully. Black carbon or soot consists of small black particles as seen in the dark smoke. They are very small, and these tiny particles are the third largest in their global warming potential. The main source of these particles is the burning of biomass like forest fires. Some other examples are agriculture waste fires and domestic fires to cook and heat. Black carbon has a very short life and gets washed down with rain. But the reason for scientific worry is that it settles down on snow as a dark layer and increases the speed of melting. This effect is being seen in Himalayan glaciers and also in the Arctic. Halocarbons. Halocarbons are totally man-made gases and are primarily used in industry as solvents, paints, refrigeration, fire retardants, etc. Though the percentage of these gases is very small, and decreasing after the Montreal Agreement of 1987, they are extremely dangerous as they destroy ozone. And these gases also have a warming potential 10,000 times more than carbon dioxide. Carbon monoxide is produced from cars and trucks. It is also released from burning biomass. The volatile organic compounds, or VOC in short, are industrial products and generally used in the industry. These gases produce low-level ozone, which acts as a greenhouse gas and is unhealthy for plants and animals. Nitrous oxide increased by 18% from the time industrialization started, primarily due to industrial production and use of nitrogen-based fertilizers. Other sources of the gas are oceans and biomass burning. The problem with the gas is that it stays in the atmosphere for more than 100 years and is difficult to remove. As we have seen that the alarming increase in greenhouse gases is leading to climate change, scientists wanted to study and verify their role to support the claim that they are responsible for the climate change. It was important to get air samples which could throw light on the composition of air way back in history. A good source was found in tiny air bubbles which are trapped when snow falls, becoming compact ice with pressure. Scientists found in Antarctica and Arctic ice which had not been disturbed for thousands of years. The ice phase showing numerous annual layers were easy to find in these places. Reading them is similar to a forester reading tree rings. The layers make it possible to go accurately back in time to learn what the carbon concentration in the atmosphere were year by year, even thousands of years ago. From this data, we know that carbon dioxide levels today far exceed the natural variation over the last 600,000 years. Here is an example of the ice core with band of volcanic ash. These ice cores have become a concrete source which allows scientists to measure, plot, and compare the carbon dioxide levels over time. Let's study what they have found. This graph shows the relationship between carbon dioxide and the temperature. In the past 800,000 years, the concentration of carbon dioxide stayed below 300 parts per million. Although this graph only goes back to 800,000 years, scientists now know that carbon dioxide didn't stay above 300 parts per million in a million years prior to the Industrial Revolution. It is obvious from these figures that carbon dioxide and temperature are a coupled system. It's hard to ignore that when one line goes up, the other line goes up too, and when one line goes down, the other line goes down. Since 1880, records for temperature are being kept, and the 10 hottest years on records have occurred in the last 12 years, with 2010 being the hottest year ever.